I love math. I love math.
Hey guys, Happy New Year. Lesson 3.1, Intro to Data Collection. Learning targets. Learning target number 1. Distinguish statistical questions from other types of questions. Learning target number 2, identify the population and sample in a statistical study. And learning target number 3, distinguish between an observational study and an experiment. Alright, learning target number 1, distinguish statistical questions from other types of questions. A statistics problem starts with a statistical question, not just any question will do. A valid statistical question is based on the data that varies. Data that varies. Data that varies. Okay. Let's take a couple of notes and we'll do a bunch of examples here. How to complete a statistical problem-solving process. The first one is to ask questions. Ask questions, clarify the research problem, and ask one or more valid statistical questions. Second one is to collect data. Design and carry out an appropriate plan to collect the data. Is the COVID vaccine working? The next one is to analyze the data. Use appropriate graphical and numerical methods to analyze the data. And then lastly, interpret the results. Draw conclusions based on the data analysis. All right, let's go through these examples. Example number 1, determine if each of the following is a valid statistical question and then justify your answer. Remember, we're going to go back to the idea that the data, we want, it's a valid question if the data varies there. Okay. I call these questions A through, I think, F or G. How many letters are in my last name? So this one is a no, and the reason why is no. This question is not answered by collecting data that varies. Let's try another one. B, how many letters are in the last names of the students in my 6th grade class? This would be a valid statistical question. Why? There is variability. Remember that back question, variability was back in chapter 1 is the spread in the lengths. No, in the last names, oops. Of my 6th grade class. Okay, so something I want to point out is this one is a bunch of students and names. It's going to vary, right? But the last question, this is only one person. Okay, C. What are the colors of the shoes worn by the students in the school? Is that going to vary? Yes. So, yes, we expect variability the colors. Okay, D, what is the maximum number of feet that the roller coasters drop during a ride? Okay, question is, in the different types of roller coasters, Supreme, Scream, Ghost Rider, is there going to be variability? The answer in this case is going to be yes. Yes, we expect variability. In feet. Feet dropped for each, for the different roller coasters. It's not all the same. Alright, if you go on the little kiddie ride and the different rides, they change, right? Okay, E. What are the heart rates in a 6th grade class? Are those gonna vary? Yes. Yes. Varying heart rates. Everyone will have different heart rates. Okay, on the next page, go ahead and try F, G, double A, double B, double C, and then press play, and we'll go over those. Usually get when they go have school the next day. Does that vary? Yes. Is it valid? Yes. Of sleep. Will vary. Basically, what you're trying to get is a variety of response. Do compact cars do all the compact cars like my Corolla get the same amount of miles per gallon fuel efficiency? We expect compact cars to get different fuel efficiency. Double A, how many days did students session? Yes. Why is that the case? The data, where the number of days will vary among students in how much played, right? You might have a student who played 27 days, or you might have someone who does 4 or 3, right? And then gives us a list of numbers that we can use. Which gender is more likely to choose vanilla over chocolate ice cream? Is that valid? It is. The answer will vary whether each person whether they were choose male or female would choose chocolate or vanilla ice cream. And the last one, how many people in the United States were convicted of violent crimes last year? If you just type that into the internet, what you get a bunch of different answers. The answer would be no. The answer is just one value. We would need varying answers. So a better question to ask, a better statistical question to ask would be, in the United States, how many, what were the different types, not types, that would be categorical, how many violent crimes were committed last year by the different ethnicity groups or gender groups, based on gender groups or based on different states, time of day. You're going to get a bunch of different answers. That's the main idea. Okay, let's move on now to learning target number 2. Identify the population and sample in a statistical study. The population in a statistical study is the entire group we want information about, from which we collect. This is called a sample. I want to use blue. So this is the population, right? Think of the United States. And in a sample, it's super small there. Well, how do you collect it? Kind of, a census collects data from every individual. Now, the United States, I think, only does this every 10 years, and it's difficult to get everybody because it's very costly, takes a lot of time to track down people. Sometimes people are sleeping. All right, identify the population and sample in each of these settings. 2A. A wild records their weights and then releases them. All right, let's use our color themes. Color scheme. So we said population was blue. So what is our population here? Our population is all the grizzly bears. All grizzly bears. Where? In Alaska. And our sample, remember sample is just the individuals, so we use green. Our sample is the 42 grizzly bears in the state. Grizzly bears in the state. Okay, a teenager selects 15 Beyonce songs and counts the number of words in each song. Okay, so our population, another good word for population is all, right? So if you take all the songs recorded by Beyonce, and then the sample is you're just taking those 15 songs and then you count each word in those. So that's important for us to figure out the population and sample. So the sample is the 15, that's going to be Beyonce's songs. All right, once you press pause and try 2C and 2D, and then we'll go over those together. The mentor plans to survey local businesses about the importance of students as customers. From a telephone book listings, the mentor staff chooses 150 businesses at random. Of these, 73 return the questionnaire mailed by the staff, identifying the population and the sample. So they want to survey the local businesses. So they're doing all of the local businesses here. So all local businesses. Okay, now you have two choices for the numbers here for the sample. Is it the 150 or the 73? And the answer is the 73 that return it. All right, 2D. Archaeological dig turns up large numbers of pottery shards, broken stone tools, and other artifacts. Students working on the project classify each artifact and assign it to a number. The counts in different categories are important for understanding the site, so the project director chooses 2% of the artifacts at random and checks the students' work. Identify the population and sample. So where is the all? All is all the artifacts. And then the archaeological expert, the project director, is only going to choose what? The sample that he's picking is 2% artifacts chosen. All right, here's my real life example. Super old Toy Story. And in the movie, they have something called the claw, right? And the claw is going to get those little aliens. Well, all the aliens, this is the population, right? But the claw only picks one. Ooh, the chosen one, right? And that is our sample. Okay, hopefully that real life example helps. Let's go on to learning target number 3. All right, page 4, learning target number 3. Distinguish between an observational study and an experiment. Observational and an experiment. An observational study. Oops, I wanted to use purple. What do you do when you observe? You observe individuals and measures variables of interest, but does not attempt to influence the response. It's kind of like you go bird watching. That's observational. Or what some people do is they do back in the day people watching, right? You sit on the bench and just watch other people at the mall or walking around. Maybe that person who goes into the video game conference room and you don't participate in the chat, you're just watching what people say. Okay? And a blank is a deliberate imposes some treatment on individuals to measure their responses. This is an experiment. Well, what's the distinction between observational study and an experiment is one of the most important ideas in statistics. So the goal of an observational study can be to describe some group or situation, right? Maybe you describe what is happening what's happening to a group based on your observation, right? Maybe when the first COVID happened, they were observing a lot of deaths were in senior citizen home, people who are older and who. You can also compare groups. Right? How about the people that were allowed to go outside versus those who were who had to stay inside senior citizen homes and who had higher or lower COVID rates? Or C, or to examine relationships between the variables. So the variable I gave was outside, inside. That's my son. All right, the purpose of an experiment is to determine if the treatment causes a change in the response. So my treatment in that case was the sun, right? And are people getting better or worse? In an observational study, even one based on a random sample, to gauge the effect the changes in one variable have on another variable. When the goal is to understand cause and effect, experiments are the only full source of fully convincing data, right? They want to know if vaccine number 1 or vaccine number 2 for COVID is going to work. And how that works is, eventually we'll talk about this, but they give the real stuff to some people, or they call it a placebo or nothing to someone else, and see if it actually works and what's its efficiency rate. All right, let's do a couple examples here. Example number 3. Do fast-paced cartoons affect our behavior? Determine whether each of the following settings describes an observational study or an experiment. Explain your reason. 3A. 64-year-old children were randomly divided into 3 groups. One group was shown a fast pace. So as I do this, I'm actually going to break this up as a visual. I'm going to create a flow chart. Super, super helpful to understand the problem. There are 60 of them. And in the 60, they are divided into 3 groups. So 20, 20, whoops, that should be his third, and 20. Okay? In each of these groups, this was the fast-paced. One group was shown educational, and one group was given art supplies. I don't know. I need to draw pictures, so I guess they're just drawing there. So, educational, and one was fast-paced. Okay? So, this is what our 60 looks like. Afterwards, the 4-year-olds who watched the fast-paced cartoon scored significantly worse than other 2 groups on tests that measured the ability to make decisions. So, question. Is this an observational study or an experiment? This is an experiment. Because the treatments were the fast, educational, and to draw, because treatments, when posed on the 4-year-olds, some children were assigned to groups. Right? Fast pace, educational, and to draw. Okay, so think about it. They actually went into, or those 60, let's just say it's like, I don't know, daycare center, right? And the scientists or the statisticians, the doctors are actually going in there and doing something, right? They're intervening, they're being proactive, they're actually doing something, they're not just sitting there and observing. Does that make sense? Okay, let's try this next one. 100 teenagers between the ages of 16 to 18 were surveyed. I always like to draw a little picture. You have your 100 teenagers. The teens were asked whether, as young children, they watch fast-paced cartoons more often, less often, or about equally as often as, or equal, as educational cartoons. They were also asked to reveal their GPA. And the teens who watched fast-paced cartoons more often than educational had lower GPAs than teens from other groups on average. Okay, so they're asking these teens, a couple of things. What do they watch? Right? And then what was the second thing was kind of like, what is their GPA? And that's actually what we studied last. You could use a bivariate two-variable statistics, what we learned previously in chapter 2. But is this an experiment? Are the scientists actually going in there and doing something? Or are they simply just observing? Well, it's an observational study. Because there were no treatments imposed on the teens. The teens, so were not told which cartoons to watch and how often. And if you think about it, if you go back to my Toy Story idea here, the observational would just kind of be watching those little aliens inside the little bubble, right? But an experiment is kind of like the claw. It's doing something. It's intervening. It's saying, okay, let me split these into two groups. Those who are closest to the window, and those who are closest to the center, right? Who gets picked more? You're actually imposing something, or you give sugar to some of those and non-sugar. Who gets picked? Those who are standing on their feet. This half, you guys stand on your feet, and the other half, you stand on your heads. Who's going to get picked? Does that make sense? So, observational, you're just simply observing. Okay, go ahead and press pause, and let's review it all. You do example number 4 that does everything that we just learned. All right, let's go over this one. Last one, review it all. Researchers at Columbia University random selected 1,000 teenagers in the United States for a survey. According to the ABC News article about research, teenagers who eat with their families at least 5 times a week are more likely to get better grades in school. What is the statistical question that the researchers were trying to answer? So, who are they focusing on? They are focusing on teenagers. So for teenagers, is there an association? I capitalize this word because it is something we learned previously. Between, what are the two things? how often they ate, right? Frequency of eating dinner with the family and what was the other one? Grades in school. Is this a valid statistical question? This is a valid statistical question. Here's my reasoning. Because the data can vary in number of times eaten with family and their GPA, right? Someone who eats little with their family can have a high GPA, or someone who eats all the time with their family can have a low GPA, or a bunch of different things, right? Okay, who is our population? So teenagers in all teenagers in the USA. Who is our sample? Our sample is the 1,000 survey. Is this an observational or an experiment? Did scientists, statisticians, doctors do something? Okay, when you're asking a question of someone, it's actually an observational, right? So the answer is observational. Observe observational study. How do you explain something? Because there were no treatments. There were no treatments imposed on the teenagers. And yeah. In other words, the teenagers were not told to eat dinner with the family, to eat dinner. The Claude did not pick them up out of their rooms and put them, right, with their families. A certain number of times per week. Right, the Claude didn't say you must, in this experiment, you're gonna eat with your family 3 times, and we're gonna measure your GPA after a quarter or something like that. Alright, so we did learning in collecting data. We talked about distinguishing statistical questions from other types of questions, right? We need something that varies. Number 2, identify the population and sample of the statistical study, so all versus some. And distinguish the observational study and the experiment, right? Is it just sitting in there in the bowl, those little aliens in Toy Story, or the experiment where the claw comes and moves you around and does something to that. So that's lesson 3.1. See you guys.
I love math.